Today we're going to start to look at related rates specific to the shape of rectangles. At the top of your notes there are 5 steps listed which you should review and familiarize yourself with. Before we get started, I want to make a connection to something that we've done before. As you can see in this example, back at the beginning of Unit 4, you were asked to differentiate when equations had both x and y variables. When we did this, we used a process called implicit differentiation. You were taught to attach a dy dx to any differentiation involving y. So as you can see on the first line, I would take the derivative of each of the left and right sides, and if I had to take what is the derivative of y, I would attach a dy dx. We then would use algebra to rearrange the terms, put all of the dy dx terms on the same side, GCF the dy dx, and ultimately solve for our derivative. Okay? Today we're going to use a similar process of dy dx, attachment, but we're not necessarily going to use the letters of x and y. And what's interesting is that any variable that is not a constant, such as pi, okay, any other variable, a, l, w, p, all are going to have their own notation similar to the implicit differentiation techniques we've used before. So let's review the steps again, taking a look at example 1. Okay. In example 1, we're dealing with the shape of a rectangle. So we're going to make a drawing just to keep all of our variables straight. Okay. I'm also going to use L across the bottom and W for my width in all of my drawings. Okay. As I read through the problem, I'm told that the actual length is going to be 4 and that the width is going to be 3. Okay. I'm also told that the length is increasing by 5 inches per minute. So we're going to call that dl dt. And it's increasing, so I'm going to call it positive 5. That is my rate of change of the length. However, the width is shrinking. So dw dt, the change in width over time, is going to be negative 7 inches per minute. What is the rate of change of the area? Okay, so this first lesson is going to be much simpler compared to the later lessons. So keep in mind all of the different parts about what that I'm saying. So the rate of change of the area, the first thing we need to do is to write down a formula for the area of a rectangle. A equals L times W. Okay, when we talk about rate of change, that is another word for slope. We've learned that slope relates to derivatives. So we're going to take the derivative of this equation. Being that there are 3 variables, we're going to implicitly differentiate. Okay, and we're going to include, as I said in the introduction, more of these dl dt's, dw dt's, and also dA dt. So on the left side, the derivative of A is going to be dA dt. This is going to be an example of the product rule, so I can go ahead and set up for that, where this is L and this is W. My derivative for W, when it's a singular W, normally would be 1. However, I need to write dw dt and attach that. This is going to be dl dt, attach that. Okay, now unlike the other example I showed you, there's no regrouping that's going to happen here. But I'm going to find the rate of change, so I want to solve for this is the variable that I'm going to solve for by plugging in all of the other information. So L is going to be 4, dw dt is negative 7, the width is 3 and dl dt is 5. The change in A with respect to time is going to be negative 13, and then we also need to include the units. So if we think of area, area is length times width. In the original problem, we were talking about inches per minute. So this is going to be inches squared per minute. Okay, you still need to think out your units a little bit. And that's it. Let's do another one. Again, we're dealing with a rectangle, has a length of 10 and a width of 3. I was told that the length is decreasing dl dt by negative 2. dw dt is shrinking also at negative 1. My formula, again, I'm asked to find the rate of change of area. So I'm going to set up an area formula for a rectangle. Take my derivative, which happens to be the same, I understand, as the previous. So don't memorize it, but really think through the process. So this is going to be L, W, okay. Now, as you read through my notes, you might wonder, well, why are these different variables? It's because we're using the product rule. So L times the derivative of W plus W times the derivative of L. From here, I'm solving for dA dt. So I can plug everything in. My length is 10. dW dt is negative 1. My width is 3. My dl dt is negative 2. This gives me a final answer of negative 16. Again, we want units. Our units are going to be inches squared per second. Now, our last example, notice that we've changed our calculation from area to perimeter. The process starts out very much the same. Rectangle, length, width. My length is going to be 12. My width is going to be 6. My dw dt is 3. My dl dt is positive 7. This is also positive 3. The difference is now I have to write not an area formula, but a perimeter formula. Perimeter is going to equal 2L plus 2W. This is not a product rule anymore. These are simple variable terms. So my derivative of the P is dP dt, 2 dl dt plus 2 dw dt. The change in perimeter is what I was solving for. So dP dt is going to equal 2 times something plus 2 times something, where dl dt is 7 and dw dt is 3, which tells me that this is changing at 20, and then my units. For perimeter, my units don't change when I'm adding inches to inches to inches. So 20 inches per second is how much it is changing by. The last thing I want to do is go back to my previous example that I gave you in the warm-up. This was the implicit differentiation when we were only dealing with y. And now on the right is the example of the differentiation when we have 3 variables. Notice how over here I attach dy dx only to the y terms. But over here, all 3 variables had an implicit part attached to them when I took the derivative of that variable. Okay, I have this in quotes as dy dx to connect to what you know is from the previous lessons. However, that is one of the differences between these word problems and what we did in lesson 1. If you have questions, let me know. You're welcome to use the homework helper also to ask questions about the notes.